Hey guys, so I have been asked to do a question or two around surface area and volume, but specifically on the shapes that you see from 99 and 100. So those are cylinders, right? So 99 is a cylinder that is kind of sitting on its base, facing up and down, and then 100 is a cylinder laying on its side, like a can basically that's been tipped over, right? So you've got looks like a can of tuna here. This looks like maybe a soda can on its side. So they're going to be very similar. In fact, the same method. So I'm going to show you 99. The only difference, and I'm not going to do 100. I'm going to let you try 100 on your own. And if you still need me to do it, ask me later and I will. But the only difference between 99 and 100 really is this one's on its side. So if you tip it up, now that 13 millimeters is the height. And then the other piece that's different is the 9 millimeters here. That's the diameter. And this one here, the 7 centimeters, is the radius of that circular base, right? So if you needed to find the radius, half, right? Half of the diameter is the radius. So I'll give you that hint for number 100, but let's do 99 together. So when we look at it, I'll do my best to draw it. Sometimes my art needs a little help, but hey, that wasn't so bad. So we know that we're looking at 7 centimeters. I did that wrong. That's 7 centimeters is that radius of the base, and the height here is 3 centimeters. So let's start with surface area. So surface area, and I'll abbreviate for SA, is all of the area, the outside, as if I was going to paint this can. That's the surface area. How much paint do I need is the surface area, right? So if we think about what this shape is made out of, so the shape of a cylinder really has two circles, a top and a bottom, the bases, the top and the bottom, as well as this outside piece. And if you've got canned food in your cupboard, you take a can, and if you take off the package, the wrapping of the can, like the paper that goes around the can, it's really only a rectangle. The shape of the outside of that, if you were to cut it here and unravel it, it would be a rectangle. So I need to find the area of each of those pieces. So we know the area here. First of all, again, this is 7 centimeters for each of the radius, the radii of each of the circles. And then I know the height of this, right? The height of this rectangle, or the width here of that rectangle, is still 3 centimeters. Because if you unravel it, that's what it is. The question is, what is that length, right? We have to find that length. Well, that length there, if you think about it, is the distance around the circle, right? So that whole distance around the circle. So that length is the circumference. So how do you find the circumference of a circle? Circumference of the circle is, if you forget, it's the diameter times pi. Okay, diameter times pi. So diameter, remember, diameter really is the length of the circle from end to end. So it's basically twice the radius. So the circumference, this length is going to be 14. And then pi we know to be, we're going to use as an estimate, is what it says on the worksheet, to use 3.14. So really what that length is 14 times 3.14. So if I want to find the area of this, it's those two multiplied times this. Okay, so we'll look at that in just a second. The area of each of those circles. How do you find the area of a one circle? The area of a circle, just as a reminder, area of a circle is pi times the radius squared. So that's the area of a circle. So in both of these cases, it would be 3.14 times 7 squared, right? So that's the area of one circle, and then I would just have to multiply that by 2. So I'll let you do the math on this one. So the surface area is going to be 2 of these. So it's going to be the surface area is going to be 2 of the circles, and the circles we just said were 3.14 times 7 squared. That's a squared. And then the addition of this plus the area of that rectangle, and the area of the rectangle is that 14 times 3.14 and then times 3, right? So the area of a rectangle is length times width. So if you do the math to here and do all the number crunching, you should come up with the right answer. Okay? And I'll let you finish that one out and figure that one out. So the volume of a cylinder, okay? The volume of a cylinder, here's a good way to picture it. Volume is always the stuff inside. What's inside of a cylinder? So if I were to be able to stack up, if I knew the area of this circle and I was able to stack them all up, all the paper thin circles all the way up, that would be the volume. That's what would fill it up, right? One of those bases filled all the way up would be the volume, all the stuff inside. So volume is really just, it's the area of the base, and I multiply that by the height. So the height, move that a little bit. So area of the base times the height is the volume of a cylinder. Okay, so in this case, I think you can go from there, right? So we knew the area of one of these bases. We just figured it out in order to do the surface area. So the area of one of these bases is going to be 3.14 times, right? The times that 7 squared, because the area is pi r squared for a circle. And then, so volume equals, and then on top of that, so that's just that area of the base. That's this piece. That's the area of the base. And I need to take that now, that whatever that gives me, and multiply it by the height. And in this case, we know the height is to be 3 centimeters. Okay, so there we go. I'll let you crunch those numbers. Keep in mind when you're done, though, volume is always in cubic centimeters, or cubic, whatever the unit is, in this case in centimeters. And then surface area, though, surface area is going to be squared, centimeters squared. So whatever goes there, but centimeters squared, because area is squared units, volume is cubic units. All right, there you go.